KISS Dependency Injection. Keep it simple, stupid. Hello and welcome to episode number 28 of the Unity Performance Task Force podcast. I'm your host Ruben from TheGameDev.Guru, and as usual I'll kick things off with a question for you. Have you ever spent 5 hours debugging a dependency injection framework only to realize the problem was a single misconfigured binding? Sounds familiar? If so, this episode is for you. Dependency injection helps you comply with the single responsibility principle. Your classes should do what their names imply and nothing else. And when I say nothing, I mean really nothing. It's not a class's responsibility to fetch references to other classes like singletons, gifstemplot, or fucking Duffy. For example, a player class shouldn't go look for the appropriate backend reference to send updates. If you did that, you'd violate the single responsibility principle. The solution? Someone should give you the references you need. You shouldn't fetch them yourself. Dependency injection also helps you implement unit tests more easily and accomplish faster iterations. For example, if your player has a hard-coded backend reference, you can't easily swap it for a mock backend. But with dependency injection, you just tell the system that the backend is implemented by a different class, like a mock backend. You swap components in one place instead of everywhere. Instead of a direct reference to the backend class, you use a reference to an interface iBackend. This way, you can swap implementations easily. So, what is dependency injection? It's incredibly simple. It's a system that gives you references. It takes care of assigning references between objects, and it does it for you. You don't have to violate the single responsibility principle. Now here's the problem. Dependency injection systems can become messy really fast. I say this from experience. They might be difficult to learn, difficult to use, and complex. Take Zenject for example. Last time I checked, it had over 20,000 lines of code. One game I used it on had fewer lines of code than that. If you ever have a problem with a dependency injection system and you need to debug 20,000 lines of code, good luck. You don't even know where to start. This is where I start to feel like I don't want to deal with dependency injection anymore. Using a simple dependency injection system is key. If it's simple, you can understand how it works and why it works. It helps you understand the steps to use it and the steps to debug it. Using it becomes trivial, maintaining it is easier, and the smaller it is, the easier it is to make it performant. That's KISS, keep it simple, stupid. Or keep it simple, comma, stupid. I like the first variation better. So how do you apply KISS dependency injection? Let me show you a system I worked with while developing a game for a company called VUGA in Berlin. It's not my system, I didn't create it, but I'm giving it to you free of charge because you're part of the membership. The license is MIT, so you can use it however you want. I found a mirror because the original GitHub repository was removed. You can download the package from the lesson. So the dependency injection system has one main component, one file. That's it. Remember the KISS principle? Keep it simple, stupid. Only one file. 150 lines of code. That's what you get. Here's the process. First, import the package included in the lesson. Second, create an injector instance. The injector is just a dictionary that holds references to types. For example, the key is iBackend and interface, and the value is the backend object you created, could be the real backend or a mock backend. Third, bind your objects into the injector. This populates the dictionary. You're making the injector aware of what objects you have. Fourth, inject these objects as appropriate into your classes. For example, if you bind the backend into the injector, you just need to tell the injector to inject references into whoever needs the backend, like your player. Let me show you in Unity. You have a player script that kills an NPC every frame. When you kill an NPC, you execute a player level up transaction. The transaction increases the player level. Now, if you want to introduce a backend, you need to send updates. In the transaction, you'd call backend.updatePlayerProfile. But how do you access the backend? You could do backend.instance.asingleton, but that's a hard reference. You're violating the single responsibility principle. Instead, you keep a reference to the interface iBackend. But how do you get that reference? Someone gives it to you. That's the whole point. Here's how you do it. In your Bootstrap script, where you set up the entire game, create an injector instance. The injector is just a dictionary. Create it with new injector. Now bind objects. You want a backend reference in the transaction, right? Create a new backend and bind it to the injector with injector.bindIBackend new backend. The interface needs an attribute injected. This tells the injector that this interface can be injected. Now in your transaction, declare a field inject private iBackend backend. The inject attribute tells the injector to give you a reference. Finally, call injector.iInjector transaction. The injector looks for fields with the inject attribute and assigns the right references. That's it. You created the injector, bound the backend, and injected references into the transaction. One more thing. You can call postbindings to inject into everything you bound. For example, if the backend relies on something else, like a logger, you can inject into the backend automatically with postbindings. So what's the performance cost? Reflection is not super cheap, but you don't necessarily do this every frame. You could pull transactions and inject once, or make transactions structs instead of classes and use generics to avoid boxing. With generics, 6 doesn't box structs and you get 0 allocations. But only optimize if you need to. If you execute a transaction every few minutes, don't obsess over allocations. Complexity adds cost. Before you implement fancy solutions, ask yourself, do I really need this? In my experience, the transaction pattern and dependency injection together are invaluable for sensitive data like player profiles in multiplayer games. It helped me a lot in Diamond Dash. I recorded backend requests and responses in JSON, then tweaked them. I created a mock backend that replayed responses without calling the real backend. This let me develop features fast without needing multiple devices. So, to sum up, dependency injection is a system that gives you references. It helps you comply with the single responsibility principle. Use a simple system, one file, 150 lines of code, so you can understand, debug, and maintain it easily. Bind your objects, inject references, and keep it simple. If you found this podcast episode useful, you can access in-depth lessons in the Unity Performance Task Force program at www.performancetaskforce.com. And if Unity Consulting is what you are after, book a free discovery call at https://consulting.thegamedev.guru. Till next time.